Solving equations. Solve the quadratic equation z square plus 4z plus 13 equal to 0. In first method, we find the discriminant b square minus 4ac. We get minus 36. We can write square root of minus 36 as 6i. So applying the quadratic formula to find the root of the quadratic equation, z equal to minus b plus or minus square root of b square minus 4ac over 2a. If we apply the values, we get minus 4 plus or minus 6i over 2, and if we simplify, we can write it as minus 2 plus or minus 3i. Another method is writing the given quadratic equation in completed square form as z plus 2 whole square plus 9. We can write it as z plus 2 minus 3i times z plus 2 plus 3i equal to 0, and it has roots z equal to minus 2 plus 3i and minus 2 minus 3i. Complex numbers z equal to x plus yi, z star equal to x minus yi are conjugate complex numbers. Their sum z plus z star is equal to 2x, and product z times z star is equal to x square plus y square are real numbers, and the difference z minus z star is equal to 2yi is an imaginary number. If a quadratic equation with real coefficients has two complex roots, these roots are conjugate. If s and t are complex numbers, then s plus or minus t whole star is equal to s star plus or minus t star. St whole star is equal to s star times t star. S over t whole star is equal to s star over t star. If z is a complex number and n is a positive integer, then z to the power of n whole star is equal to z star whole to the power of n. If a is a real number, then a z power n whole star is equal to a times z star to the power of n. If p of z is a polynomial with real coefficients, then p of z star is equal to p of z whole star. If s is a non-real root of the equation p of z equals 0, then s star is also a root. That is, the non-real roots of the equation p of z equal to 0 occurs as conjugate pairs. Show that 1 plus I whole to the power of 4 is equal to minus 4. Hence, find all the roots of the equation z power 4 plus 4 equal to 0. First we take 1 plus I whole square. If we simplify, it is equal to 2i, and if we square on both sides, we get 1 plus I whole to the power of 4 is equal to minus 4. So we proved the first part. For the quadratic equation z power 4 plus 4 equal to 0, since the degree of the polynomial is 4, there will be 4 roots. So this shows that 1 plus I is a root of the equation z power 4 plus 4 equals 0. So another root must be its conjugate pair, which is 1 minus I. So far we have found two roots of the given polynomial, so we need to find out two more roots. You can deduce that z minus 1 minus I and z minus 1 minus I, that's equal to z minus 1 plus I, are both factors of z to the power of 4 plus 4. So the product of the two factors z minus 1 minus I and z minus 1 plus I, if you multiply both of them, their product, that is z square minus 2z plus 2, should also be a factor of the given polynomial. So we can write the given polynomial as in factors forms as z square minus 2z plus 2 times z square plus 2z plus 2. So taking the one of the factor, that is z square plus 2z plus 2 equals 0, and finding its roots, we get minus 1 plus or minus I. So these are the two roots that we are looking for. Now we got four roots for the given polynomial. There are two conjugate pairs of the roots, 1 plus I, 1 minus I, and minus 1 plus I, minus 1 minus I. Solve the equation z power 5 minus 6z power 3 minus 2z square plus 17z minus 10 equals 0. This equation should have 5 roots. So first we take z equal to 1 and find p of 1. Its value is 0. So z minus 1 is the factor of the given polynomial. So we can write the given polynomial p of z equal to z minus 1 times q of z, where q of z equal to z power 4 plus z power 3 minus 5z square minus 7z plus 10. And now taking z equal to 1 and finding q of 1, we get 0. So we can write q of z as z minus 1 times r of z, where r of z is equal to z power 3 plus 2z square minus 3z minus 10. Now again, if we take z equal to 1, we get a non-zero value for r of 1. Now we try with z equal to 2 and r of 2 equal to 0. So we can write r of z equal to z minus 2 times z square plus 4z plus 5. So we can write z square plus 4z plus 5 using completing the square method. We can write it as z plus 2 whole square plus 1 is equal to z plus 2 minus I times z plus 2 plus I. So now we have the factors. Thus p of z equal to z minus 1 whole square times z minus 2 times z plus 2 minus I times z plus 2 plus I. And the roots are 1 a repeated root, 2 and the conjugate complex pair, minus 2 plus or minus I. Totally 5 roots.